Hey everyone, so I'm going to start talks off with a question. So the question I came up with for today is, what does Minority Report, the TV show Person of Interest, and a random tool I made one evening all have in common? Super riveting question, I know, I'm sure you're all at the edge of your seats. And the answer is that they all use machine learning or some sort of prediction technique to identify malicious activity. And that's what we're going to be talking about today. So in Minority Report, we have precogs, person of interest, we have the machine, and this random tool I made one evening is using binary classifiers to identify malicious configurations in Android applications. And I wanted this talk to have two key takeaways, right? Because I appreciate not everyone here is going to be super interested in Android reverse engineering. So the first takeaway is just about that, right? We're going to be reverse engineering some Android applications. We're going to be taking them apart, figuring out how they work, and using this machine learning classifier to identify malware. And the second key takeaway is more broad, right? It's about how we can apply techniques from one field to another field. So in this case, I'm applying some data science, some malware analysis, to reverse engineering, right, which is what I do for data. So, first things first, who am I? Well, my name is James Stevenson, and this time, I want to say 6 years ago now, but that makes me feel old, I graduated from the University of South Wales studying computer security. Since then, I've worked as an Android internal software engineer, I've worked as a penetration tester, and these days I'm working as a vulnerability researcher for the startup Interrupt Labs, and there's a good handful of us, Max, Mike, and a few others from Interrupt Labs here today. So if you want to know what we do, feel free to grab us. I've also spoken at a few conferences, I'm doing a part-time PhD, and I have a few books out there as well. So, what are we actually going to be talking about? Well, first of all, I want to talk about Android reverse engineering, right? I want us to have a look at a few Android applications, take them apart, figure out how they work, and to get really everyone onto the same page, right, on when it comes to Android reverse engineering. Then we're going to have a look at Droid Detective. Now, Droid Detective is this tool that I've made that allows us to take an application, strip it apart, and figure out what's happening. Then I want to talk about the data science part, right? So I want to talk about the machine learning model behind Droid Detective, how it actually works, if it works or if it doesn't work. And then finally, I want to go through a demo. Now, I'm not brave enough to do a live demo, so it is a recording, so I know how it works. It's great. So let's jump straight into it, right? Android reverse engineering. As a software engineer, we're going to write an Android application commonly in either Java or Kotlin. That then gets compiled down into a Dalvik executable. That Dalvik executable is basically what's run on the device. There's a few additional steps there, but for the sake of this talk, it's what's run on the device. As reverse engineers, we can not read that, right? It's not human readable. So we can do two things. We can either disassemble it or decompile it, right? Decompiling it to pseudo-Java, the decompiler's best guess at what that Java would look like, or we can disassemble it into SMART, right? A human-readable representation of that Dalvik executable. But what we're doing today, we actually don't care about the code. We specifically care about the APK. And the APK is basically a bundle of information, files, and other bits and pieces, that tell the device how to run an application. There's a few things in there, including the Dalvik executable and some resources and some files. And there's a brief example here. So we've got some assets, basically arbitrary storage, we've got some native libraries, we've got that Dalvik executable. And then what we actually care about today is this Android manifest file. That's basically a configuration file that includes everything the device and the app need to know to run. So they look a bit like this. He says, there you go. Bunch of XML, right? And it has a few things in it. So it's got its package name, package ID, some components, entry points. As I said, basically everything the device needs to know to run that application. But again, what we actually care about today is these permissions. And this is an example of some permissions in one of those manifest files. And because of the way that Android is sandboxed, under normal circumstances, if an application doesn't have a permission, it can't do the thing related to it. So let's say we can look at the one in the middle, which is the internet permission, right? Under normal circumstances, if an application doesn't have that permission, it can't access the internet. So that can lead us to a few questions, especially if we put a malware analysis hat on. Because we have all of these different types of malware, right? We've got spam, backdoors, hostile downloaders, and it kind of leads us to a question of if different permissions lead to different types of activities, can we identify malware based on the permissions it's using? So let's say a hostile downloader, maybe that's using the internet permission. or maybe a backdoor, maybe that's using the boot complete permission. Spam, maybe that's using the phone permission. And that's kind of the hypothesis for this talk, right? We're asking the question of, can we identify malware, Android application malware, solely off the permissions that it's using? And that's kind of where Droid Detective comes in. So that's what Droid Detective tries to do. It tries to take an application's permissions and identify if it's malware or not, solely off those permissions. This is not happening. There you go. This is the web UI of Droid Detective. It's quite simple, and if you ever visit this website, you'll realize I'm not a web developer. Crashes probably about 50% of the time. But there is a GitHub repository as well, which in theory works 100% of the time. And we'll have a look at this later on when I show the demo. And what this basically does, as I said, takes an APK, takes it apart, looks at the permissions, and identifies it's malware. So how does that actually work? Well, there's a few data sets involved. The first data set we have is our known bad data set. And this is our malware. So this is basically a malware GitHub repository that's online. It's got a few hundred malware APKs. The second data set we have is our known good data set. Right? So for this example, I pulled 100 or so applications from the Google Play Store. The assumption being that Google Play Protect have kind of filtered out the malware. So we have our known good and our known bad data sets. We also have our prediction data set. And this is what we're going to provide the model to attempt to identify if it's malware or not. But then we have this binary classifier, right? Currently this is just a black box. Just this binary classifier. What actually is it? So it's using random forest, which I'm not a data scientist, I'm a reverse engineer, so I'm going to explain it at a high level. Basically what it's doing is it's a series of decision trees. And those decision trees are made when we train that model. And then when we provide it new data, it then goes through all of those decision trees and will either do some sort of averaging or some sort of voting to come out with that final result. And so, again, what we're looking to do is we're looking to take permissions from our Android application, go through this decision tree, and identify if it's malware or not. And there's two things that we need to bear in mind. Well, there's a few things we need to bear in mind, but two here that we need to bear in mind when we talk about data that we provide a model like this. The first is that these features, these variables that we provide the model, need to have some sort of predictive power. And what does that actually mean? Well, it basically means that those features that we provide the model need to have some sort of impact or weight on the decision that we want to identify. So earlier on, our hypothesis was that permissions would have an impact on if something is malware or not. But if we look at something else in an Android application, let's say the application name, does that have an impact on if it's malware or not? Probably not, right? Like a malware engineer can change the application name, and it has very little impact on if it's malware. The next thing we need to bear in mind is that these two, or these multiple features are uncorrelated. What that basically means is that these features aren't related to one another. So we can look at Android permissions for a really good example of that. So in Android, we have two different types of permissions. We have our manifest permissions and our runtime permissions. Our manifest permissions, they're accepted by the user at download time. And our runtime permissions, they're accepted at runtime. So that box that pops up and says, hey, you want to use the phone? But the issue with both of these as a data set is that they're quite correlated. So if your application has the read external storage manifest permission, it will also have the read external storage runtime permission. And what that will end up just doing is it will end up confusing the model. So we're going to end up just using these manifest permissions. But what does that data set actually look like, right? I've mentioned these three data sets, and that might not be too clear on the screen. But we can imagine each of these data sets like a table, right? Where at the top row, we have the permissions in the Android open source project. So that's everything from internet access to write external storage, to phone state. And then the left column, or the right column, I suppose, we have all of the applications in that data set. We then put a 1 for if it has that permission, and a 0 if it doesn't. So we can imagine each of those data sets as these kind of tables. So this is the demo. We'll see. Video can't be loaded. Cool. Well, see if I can hotspot it. Oh, I feel like I'm probably making a lot of noise on the table. There you go. it's when you try to do everything possible to make a demo work, and then in practice it makes it not work. What can you do? Okay, I think we're probably just going to skip the demo. Because there is a little helper slide after this that would have shown us what's happening. Cool. So let's imagine there was a great demo, super amazing demo. You all loved it. Such a good demo. If anyone asks you about the talk, it was amazing. So what actually happened in that demo is we took the Facebook Lite application. Facebook Lite basically being a cut-down version of Facebook. We then stripped apart the bundle of files, and we took that manifest file. And again, we mentioned the manifest file earlier on, basically an XML file. We then took the permissions from inside that file. We took the permissions from inside that file, and we ran those permissions through this binary classifier and these decision trees. That then came back with a result. In the case of Facebook Lite, it came back as true. We also ran a Trojan through it as well, which came back as malware, and the Facebook Lite came back as not malware. We'd then be able to see that in the UI, where we have, hey, this was marked as not malware, and these are all the permissions it used. So, what's it going to do? Oh, yeah, come on, you can do it. Great, cool. So, we've had that amazing demo. Now I want to talk about a few things related to this model. The first one is the scores in the top right. And again, I'm not a data scientist, I'm a reverse engineer and vulnerability researcher, so we're going to take this at a high level. The first one we're going to focus at is accuracy. And what this accuracy basically defines is the amount of times it has successfully identified malware as malware, and the amount of times it's successfully identified not malware as not malware. And this is 0.93 or 93%, which is pretty good. There are a few things that we need to think about here, things like overfitting, stuff like that, which I'll briefly cover later on. The next thing which is quite interesting is these model weights. And these model weights should really be called feature weights. And what this is it's the weight or the impact that this model, Droid Detective, has put on these features. And again, our features are our permissions. It's not happy, is it? Come on, you can do it. Oh, sure. Cool. So these are our feature weights. And again, our features are the permissions, and the weights are the impact, or kind of the weight that the model has put on each of these features. And this is quite interesting. This is quite interesting even if we don't want to use Droid Detective. It's interesting if we're malware analysts. It's interesting if we want to understand how malware works on Android, because we can have a look at these weights and understand why these weights have been put on these permissions, right? We can say, well, okay, this model really thinks that internet, that write external storage, that write SMS have an impact on the decision-making between if something is malware or not. Now, that doesn't necessarily mean that because an app has the internet permission, it's malware, but it means that it has an impact in that decision. Come on, you can do it. Hey, cool. So we're coming towards the end of the talk. Droid Detective is open source and it isn't perfect. So if anyone wants to have a play around with it, definitely recommend doing that. There's a few ideas here which kind of it needs looking into. One of those I mentioned earlier on, which was all about overfitting, right? So the Droid Detective data sets that I mentioned earlier on, we have that known bad data set, right? Our malware. We have our known good data set, the Google Play apps, and then we have our kind of prediction data sets. And the idea of overfitting is that, well, okay, maybe we've just trained this model to be really good at detecting what's in those data sets. So really, we need a better data set, right? A random GitHub repository from 4 years ago isn't a great data set. So that's one thing that can be improved. There's a few other things where we could start looking at the different types of malware, right? Earlier on, we mentioned, well, does spam have different permission sets to backdoors, right? Another great example of what we could do. Yeah, that's basically this talk come to a close. If you've got any questions, feel free to ask me now. You can find me on Twitter, or I'll be around at the Interrupt Labs kind of table later on. Thanks, everyone.